Hey guys, today is our introduction to radical expressions. So we will be able to simplify radical expressions, add, subtract, multiply, and divide radical expressions, and relate the rules of exponents to radicals. So first we're just going to talk about the key terms in a radical. So first, let's talk about what the radical is, and that's the actual blue sign is a radical. The index is the number that's on the outside of the radical, and the number that's on the inside of the radical is the radicand. So roots and powers are inverse operations, just like we talked about today in class, because one undoes the other. So let's first talk about simplifying radical expressions. We want to split up our radicand, or that number on the inside, into factors that can be simplified with the index. So first, our index in number 1 is 2, because it is our square root. And our radicand is 54. So we're going to find the factors of 54. So when I think of 54, I think of 6 times 9. So I'm going to write the square root of 6 times 9. Now we don't know what the square root of 6 is, but we do know the square root of 9. So we're going to split that up, the square root of 6 times the square root of 9. If we split up the square root of 6, we get the square root of 2 times the square root of 3, and we can't simplify either of those anymore. So we get 3 times the square root of 6 as my simplified radical. Once again, to check, I'm going to put in my calculator the square root of 54, and I'm going to put in 3 times the square root of 6 to see that I have the same answer. Sorry about that. Now I have the 4th root of 81 x to the 7th. So now I'm looking at multiples of 4. So I'm going to split up 81. When I think of 81, I think of 9 times 9, which I can then split up into 3 times 3 times 3 times 3. X to the 7th is just x 7 times. So what I'm doing when I'm trying to find the 4th root, I want to find groups of something in 4s. So since I have 3 4s, I know that I can pull out 1 3. And since I have 4 x's, I can pull out 1 x. Because 3 times 3 times 3 times 3 is 3 to the 4th power, but the 4th root of 3 to the 4th power is just 3. Then going to write what I have left. And I have x to the 3rd power. So this 3x times the 4th root of x to the 3rd power is my simplified answer. Now, adding and subtracting radical expressions. When we are adding and subtracting, we need to have like radical parts. So we need to have the same index and the same radicand in order to combine radicals. So I have 8 square root of 7 minus 2 square root of 7. Since I have the same index and the same radicand, I can go ahead and subtract 8 minus 2 to get 6 square root of 7. In my second example, I have 8 cube root of 7 minus 2 of the 4th root of 7. Since my index is not the same, I cannot simplify this any further, and my final simplified answer would be the same thing. Now, multiplying radical expressions, we are going to use the product rule for radicals. And what this is telling me is we need the same index of our radicals, and we are then going to multiply our radicands. So if we have the same index, we then just multiply the insides. So in our first example, we have 7 as our index for both radicals. So then we are going to multiply the insides. So this is equal to the 7th root of 11y to the 8th power times 2y to the 2nd power. So this is equal to the 7th root. 11 times 2 is 22. Y to the 8th times y to the 2nd. We add our exponents and we have y to the 10th. I'm going to say that this is not my final answer because I'm looking at my index of 7. And I'm looking at my power of 10. And that's telling me that there are 7 y's inside of my radical. So I can simplify that by taking out a y and being left with 22y to the 10th as my final answer. Dividing radical expressions, we're going to use the quotient rule. So once again, we need to have the same index, and then we will just, instead of multiplying, now divide our radicands. So since we have a 4 as our index in both of those radicals, I'm going to be able to rewrite this as the 4th root of 45 over 3. Which is the same thing as the 4th root of 15. And we're going to think about this here. What times what gives me 15? 3 times 5. That doesn't give me a multiple of 4 anywhere. So my simplified answer is 4 root 15. And finally, we're going to use rational exponents to relate it to radicals. So, when I have a rational exponent, I can rewrite the rational exponent as a radical. M, or my numerator, is going to be the power. N, or my denominator, will be the root. There are 2 different ways to write it. You can write it the first way, where you have the entire term being raised to the power, or where you can have it the entire term being raised, taking the root. So if we have 1/2, that's the same thing as the square root of 81 to the 1st power, which is just 81. So the square root of 81 is 9. And then we have 32 raised to the 3/5 power. So let's write that 2 different ways. We can do m is our power, n is our root. So either we can take the 5th root of 32 and cube it, or we can take the 5th root of 32 cubed. Let's try both of those. Do we know in our calculator or in our brains what the 5th root of 32 is? It is 2. So then, wouldn't that be easy to have 2 cubed, or 2 raised to the 3rd power, which is 8. I think this way would be much more simple than first cubing 32 to get 32,768 and taking the 5th root of that. But in the long run, we still get 8. We did not have a calculator. This second option would have been much more difficult for us to solve. And that's it.